Okay, now we want to talk about chemical bounding quantum numbers. Quantum numbers is N, L, M, L, M, S. I want to see what is the meaning of each. So we know electron is from nucleus. It has more energy. Farther it is. So here is nucleus, and we have orbital, right? Further is electron. Electron farthest from the nucleus has more energy because it is less bounded to the nucleus. It's more free to move. It has higher speed. Compared to the electron, it's closer to the nucleus. It has a lower speed because it's bounded to the nucleus. So the position of the electron called energy level N1, N2, N3. So electron here in inner orbital is N1. The second orbit, it is N2, is energy level. N is energy level, is your first quantum number. Second quantum number is L. What is the L? L, it's cloud of the electron, the shape of the cloud of electron around the nucleus. So if L equals to 0, the shape is a spherical. L0, the shape is a sphere. For L is equal to 1, the shape is dumpling shape. It looks like that. For L is equal to 2 is more complex. I will show you the shape of this one in the next slides. Okay, so L tells you the shape of the electron. Now, what is ML? If the L is shape, ML is orientation. For example, L0 is a spherical. A sphere is going to be symmetric. Doesn't matter which way you look at the spheres, all look like the same. Because it's symmetric, we just have one state for this sphere. So M of L gonna be 0 for that. Just one M of L. But for a dumpling shape, we could have this dumpling on x-axis, or it could be on y-axis or z-axis, right? Let's say if your dumpling could be along the y-axis. Different color, or it could be along, let's say, x-axis in 3D, or it could be along y-axis. So here is x, here is y. So we have M of L to be -1, 0, and 1. As you see, this one is along the x-axis, y and z-axis. So each, there is orientation. So M of L means orientation. L means shape. N means energy level, or how far that orbit is from nucleus. So each of these orbitals that I see here can contain 2 electrons. Since I have just one ml, so it's just one box, right? So when the ml is -1 or is along the x-axis, this dumpling shape along the x-axis, it could occupy 2 electrons. Be electron spin up or electron spin down. For 0, the same thing. It can occupy maximum of 2 electrons, spin up, down, the same. So each of this orientation, it could occupy 2 electrons. For L2, of course, M of L will be -2, -1, 0, 1, 2. As you see, we have 1, 2, 3, 4, 5 boxes. It has a more complicated shapes, but we know that's the rule. Again, each of that can occupy 2 electrons. So this is for ML -2. This box is for ML -1. This box is for ML 0. This box is for ML 1, and here is for 2. Okay. When the L is 0, we call it s orbital. We call it s orbital, right? When L is 1, is p orbital. For L2, we call it d orbital. Of course, for L, if the L is equals to 3, we call it f orbital. And again, the rule for ML is from -L to positive L. This is the ML. The rule for L, okay, so L gonna be from 0 to n-1. M of L is from -L to what? To L. So I have this rule here. I have this rule L is equal 0 to n-1 here. For M of S, okay, what is the M of S? M of S is a spin. Positive spin means your electron is a spin up. -1/2 means your electron is a spin down. In any atom, electron has its unique quantum number. You cannot find any electron with the same quantum number. For example, this electron that you see here, let's say the energy level is equal to 3 for that, for both of that. L is gonna be 2 for both. M of L is equal to -2 for these two, but a spin, one of them is up, means the first one has ms of +1/2, the other one has ms of -1/2. So it means the sets of the quantum number for each is unique. It should be different. They have their own fingerprints. So now we're doing an example. I'm gonna erase this. Maybe move to the next slide. Okay, this is an example. If L is equal to 1, n equal to 1, means L gonna be from 0 to what? n-1. n-1 is 0, so means I just have L equal to 0. And ML is 0. Again, ML is -L to L, means -0 to 0 is just 0. And a spin is going to be +1/2 or -1/2. As I just have that there, right? So it's a spherical, it's L0, it could be a spin up or a spin down. So For this electron here, the first one, I can say n equal to 1, L equal to 0, ml equal to 0, spin m of s is positive 1 over 2. For the second electron, I have exactly the same thing, but ms is negative 1 over 2. This is for a spin up, and here is for a spin down electron. Now for n equal to 2, L is from 0 to n minus 1. n minus 1 is 2 minus 1 is 1. Then the L is 0. I know ML is 0, MS is 1 over 2 or negative 1 over 2. When the L is 1, ML gonna be what? It's from negative L, so ML gonna be, look at this, from negative 1 to positive 1, negative 1, 0, 1. Again, for each of these states, we have 2 electrons, which one is spin up, one is spin down. So that was an example. Okay, we go to the next slide, hopefully. It is. Okay. As you see, just the shape of the orbital. So this is d orbital that is depicted here. This is s orbital. This is a dampening in x, y, z direction as you look at that there. But that's still kind of the summary of what we do. In s orbital, you can have just 2 electrons. In p orbital, you can have 6 electrons, and so on. That would be the summary of what we did talk about.